Okay, so this will probably be one of my last videos dealing with chapter 4. I might talk about exponents, but I might not. If there's another video that's related to chapter 4, it will definitely be on exponents, and maybe talk about square roots also, maybe. Depends. Most of these videos that I'm doing are to help you later on with the final exam. The material I cover in these videos is what I consider important. On the homework, some of the problems, the answers to those can be found in these videos, but you also have to read the book. But these videos should help you a lot on the final exam. Not just this one, any video I make. It will probably be different if this is the last video for chapter 4. Going forward, we're still supposed to cover chapter 5 and 6 also, which I probably will do, but I'll probably be a little bit, hopefully, more organized. Not that this has been unorganized, I don't think. A little bit, but not too bad. As long as you're keeping up with the reading, you should be fine, and watching the videos and doing the homework. Okay, so there's a few things about rational numbers that I didn't discuss in any video prior to this. Right off the bat, I can talk about closure of the set of rational numbers. Rational numbers is closed under all 4 operations. This means that if you have a rational number, 2 rational numbers, and you multiply them together, you're always going to get a rational number. If you have 2 rational numbers and you subtract them, one from the other, you're going to get a rational number. If you have 2 rational numbers and add them together, you're going to get another rational number. And if you have 2 rational numbers and you divide one by the other, you will still get a rational number. So that's what it means to be closed. So rational numbers are closed under all 4 operations. Next thing I want to talk about is the density of the rational numbers. So in the book, they don't get into it too much, and they say density of fractions. They should really probably say density of the rational numbers. The rational numbers are dense in the real numbers, meaning if you draw a real number line, and let's say we have 2 real numbers, I'll just call them A and B. Somewhere on that real number line, there's 2 numbers in between 0 and 1. You know, one might be 1/3, one might be 3/4. Well, what this is saying, the fact that there's density, means you can always find a rational number. There's going to be one rational number. I'll just write a rational number. There will be one. It doesn't matter what these 2 real numbers are. There will be a rational number in between them. Okay? So that means that you can even, I'm going to draw them 0 and 1 close together. Let's say there's a real number there and a real number there. So these 2 real numbers are really close to each other. There will be a rational number in between them. So obviously rational numbers are also real numbers. So one thing this leads to is that if you have 2 rational numbers, any 2 rational numbers, there will be another rational number between them. So let's figure out 2 rational numbers that are kind of close together. 1/2 and 5/9, I guess. 5/9. Hopefully you can see that. I think you can zoom in if you can't, but here, I'll write it bigger. So this one's 1/2. See, you can see it now. This one's 5/9. There will be a there's another rational number in between those two. How do you find it? Well, that's a good question. What you try to do is get the two denominators to be the same. So one thing you can always do is just multiply this one by that. So I can multiply this one by 9/9. This one by 2/2. Well, if you see what happens, hopefully you can see that. There's still not a number in between those. Well, can I change this to 90/180? That's the same as 9/18. I can change this to 100/180. Now you see that I could pick any number in between 90 and 100, such as, I'll pick 94. So 94/180, now obviously that can be simplified, but I'm not going to, right now at least. 94/180 is in between 1/2 and 5/9. Well, if you've been paying attention, I said that if you have any two rational numbers, you can find another rational number in between them. That means you could actually find, I'm going to use a different color just to be different, in between 1/2 and 94/180, there's another rational number. Okay, so let's try to find a rational number in between 1/2 and 94/180. That's easy. We just said that 1/2 can be written 90/180. So 92/180 would be in between 1/2 and 94/180. Well, if I wanted to find, now you could find another rational number in between this and 1/2. Well, that's easy too. 91/180. So 91/180 would be right here. And you can keep doing that. Now, you're probably thinking, well, really, there's one in between 91/180 and 90/180? Well, yeah, there is, because, watch this. It's kind of hard to see it on there now because everything's getting jammed together, but if I wanted to find a rational number in between these two, all I'd have to do is multiply each one by 10, 10 on top, 10 on the bottom. Then you could pick a number like that's in between 900 and 910. And then you have a rational number in between 1/2 and 91/180. It's 904/1800. And you can keep doing that. I could make this video last like a couple of 100 trillion years, and I could keep finding fractions in between these fractions. So I don't think I have 100 trillion years or whatever I said to do that, so I'll stop right there. You can try to do that. You're younger than me probably, so you might have 100 trillion years to waste. Okay, so we talked about these two. That went by pretty quick, actually, because closure was easy to talk about. If you don't believe closure, you can try pick any two rational numbers. This doesn't prove it, but you can pick any two rational numbers, multiply them together, you're going to get a rational number. Divide them, you're going to get a rational number. Subtract, add them, you're going to get a rational number. I don't remember if I talked about dividing rational numbers. So I'll talk about that too. I was supposed to. I know I did a video where I did all the operations, but I think I might have skipped division. But like I said, nothing's that important until you take the final. So if you got a problem wrong on the homework, because I didn't talk about a certain topic. First of all, you could have read about it, but also don't be afraid to watch videos other than mine. Like if you can find a video on Khan Academy or another YouTube video, that's fine. You just want to make sure you maximize your grade. So I'll talk about dividing rational numbers, but I think I'll actually do that in a different video. That way I can have a video that's just called dividing rational numbers. That's if I forgot to do it before. I think I did. And if I didn't forget to do it, then there'll just be 2 videos, I guess, that talk about dividing rational numbers. So I'll try to remember to do that. Okay, so ordering rational numbers. Well, what I mean by ordering, probably didn't really need it in quotation marks, but what I mean by ordering is if you have 2 rational numbers, how do you know which one's bigger? So, just for instance, I'm going to make up 2 rational numbers. I tried to make them up so I didn't already know which one was bigger, and I'm not even looking at them right now. This is where actually having real classes is beneficial. That way I could have asked, everybody to write down a rational number. Then I could have picked a few and we could have done it. We could have figured out which one was bigger. So I'm looking to see, like, is this true? Or is this true? So one thing you could do is go like that. Could be that these are equal to, but I don't think they are. Pretty sure that they're not, actually. How do you figure this out? Well, what you can do is this. Okay, we're trying to figure out what to put here, either less than or greater than. So, I don't know if we talked about inequalities before, but this is less than. Let's just write t because I didn't leave enough room. Less than, greater. I'll just write greater. And then, obviously, I think it should be obvious if there's a line under it, it means greater than or equal to. That would be less than or equal to if it was the other symbol. What you're going to do here is you're going to cross multiply. I think I'll do this with a different color. Checking my time, I got 13 and a half minutes. Ooh, and I can even do a different color for these. So, I'm probably going to need a calculator. That's weird that you can still see me when I'm getting bigger. I'm getting taller as the break goes on. I guess it's not even a break now that we're not coming back. It's just, I don't know what you call it, the end of the semester. As we get closer to the end of the semester, I've grown 2 inches, I guess. Alright, so, I'm kidding, by the way, I haven't really grown. You multiply 8 times 107, and you get 856. So I'm going to write, see how the 8 was one of the multiplicands, and 8's in the top, so you write 856 here. Okay. Then you multiply the other 2 numbers together. 21 times 43, you get 900. So you write that here. It corresponds to, since this is the top number of these 2, you write the product of these 2 above that one. since this is the top number in these two, you write the product above that. So then you just look to see which of these numbers is bigger. Well, 903 is bigger than 856. So guess what? You just move this down here, and it's the same sign. So 8 over 43 is less than 21 over 107. Now, that's how to do it without doing the division. You could also convert that to a decimal by just saying 8 divided by 43.186. It goes on more than that, but I don't think I have to write any more than that because I'm going to come over here and look to see what this is. 21 divided by 107. Yeah, it's 0.196. And like I said, I'm just rounding. So you can see that we were correct. 8 over 43 is less than 21 over 107. Now I know what you're probably asking. Can you do another example? Yes, I can. I will. I have to make up the numbers. Yeah. I'm not sick. I'm coughing because making these videos hurts my voice. I don't know why. I think I'm talking louder because I'm talking to a microphone. Alright, let's see. Somebody give me a fraction. Somebody said, okay, 5 over 17. Don't know why they said that, but I like it, I guess. Somebody else give me another number. One person. Oh, 8, okay. 22, fine. Now, 8 over 22 could be simplified. I'm going to simplify it as a matter of fact. I'll just write 4 over 11. Maybe you could just look, guess to see what one you think is bigger or smaller. So, we're going to, this takes extra time to do this. I can already tell which one's going to be bigger, but now, I didn't know when I made up the example. But. So, 17 times 4 is 68. Notice, see, I wrote the 68 above the 4 because the 4 is the one, is the multiplicand. The 5 isn't. So 5 times 11 is 55. Once again, we have our number being less than. 5 over 17 is less than 4 over 11. Okay. Easy, right? Okay, well, let's do another type of example. I don't have to be afraid of erasing things too soon because you can pause videos. In case you didn't know, you can pause videos. You know it now. Alright, so here's another type of example where this is important. Let's say you have 7 over 13, 8 over 16, that's not a good example, but 35 over 58. Trying to make good examples, it's kind of hard to do. Because I didn't plan before, because I don't like to. Not for these. I like to do things as they are. Well, anyway, so this is a little bit different because now we have 3. And I want to write them in order, from smallest to biggest. Smallest or largest, whatever you want to call it. So, and then middle guy. Middle guy. I won't even put anything there. I could say middle number. So I need to figure out what one is the smallest of these numbers. First of all, I'm going to simplify this to 1/2. So we have 7 over 13, 1/2. That can't be simplified, I don't think. Alright. So, what one's the biggest one of these? I can tell that both of these are bigger than that. So I know 1/2's the smallest. I'm going to just check by doing what we just did. I won't use different colored pens now. So you can see, yeah, 7/13 is bigger than 1/2. And if you did that with this one too, you'd see that that's bigger than 1/2. So 1/2's definitely the smallest. We just have to figure out what, between the other two, what one's the biggest one. So 7/13, I really don't know what this is actually. What one's bigger, I mean. I think this one's bigger. It's always good to, like I said before, it's always good to guess. So this would be 406. And let's just use black. 13 times 35. Luckily I have my calculator. Just checking. Whoop. 35 times 13. 455. These are actually pretty close. But this number is bigger. So that means that 7/13 is the second biggest, and then 35. So we took those numbers and ordered them. Now in the original problem, it said 8/16, so I'll write 8/16. Alright, well, hopefully this helped a little bit with something. It will help, definitely, if you watch it when you take the final exam. I don't know how much it's going to help with any homework problems, but hopefully it does. And I'm going to try to make a video right now after I go get a drink about dividing rational numbers, because I'm not sure if I did one before.